Okay, so maybe I'll try to keep it brief. Let me see if I manage to use Zoom this time. Can you see a slide?
Yeah.
Right.
Okay, perfect.
Yeah, looks good.
So basically I want to just give a bit of a more high level talk without going too much into the nitty-gritty details, especially because they're very likely to change as soon as we figure out the recipe system, even though maybe I'll emphasize a bit what are the requirements that I would like from the Mackie recipe system so that it's possible to implement StatsMakie in a clean way. But I think mainly I want to discuss a bit the kind of design and goals. So the basic idea is to figure out the best way to make complex plots with a simple syntax. And what to me was an interesting starting point is that this is done very different in different libraries and different programming languages. So for example, if you look at how this is normally done in R, they actually do it very different. So in R, basically your data is always in a data frame, so it's always kind of a table, and then you have a bunch of columns. And the popular library ggplot basically decide that the way you want to do a plot is that you mainly decide what's your data and what columns correspond to what feature of the plot. So maybe one column will be the X variable, another the Y variable, another the color. And then you would have what they call geometry, which is actually very similar to our plot types. So whether you're going to do a bar plot or a scatter plot and whatnot. And finally, that sometimes you will want to modify your data with what they call a statistics, which is simply a transformation of the columns. And this actually works quite nicely. So this is an example where you can build a reasonably complex plot with a syntax that's easy to read. So MPG is the typical test data set they use to kind of demo their package. And then all these little names here, they look like undefined variables to the untrained eye, but they're actually column names, and somehow it works in R. So here you're saying that displ and HWI are your X and Y axis, and the color will be the sil column as a categorical variable. So it will have 4 values overall that correspond to these numbers. And then you put in 2 geometries. One is simply the point because you want to have a scatter, and the other one is the smooth geometry, which simply means run a regression and put it on top. And you can choose many methods. So here they choose a linear regression. So basically you take the data, you split the data, and then you plot it into 2 different ways. One is the raw data with no transformation here, and then a transformed data as a basically set of lines with the shaded error for confidence. And what I thought was interesting is that in plots, we do it in a completely different way. So we don't special case data frames at all, especially because in Julia it's not particularly, well, it is a popular type, but it's not in any sense any more special than any other custom type. Instead, we have a very sophisticated pipeline to recursively process arguments. So I will not go into much detail because Daniel explained it very thoroughly. But just to summarize the key idea, basically, as a user or as a library, you keep giving rules to translate types into simpler and simpler types. So for a function, if I give you a function and the extrema, you need to compute what's a smart grid to plot this function and put it there. That all distributions need to be converted into their PDF, which is a function, so you can then use the trick above. And finally, that if I pass you a distribution, there's actually a well-defined notion of extrema, because you can find, say, the 0.01 quantile and the 0.99 quantile, and this will be your default range. And so if I define these 3 rules, and then I tell you, okay, plot a normal distribution, it will do the right thing and plot a CDF. And this is all very nice and allows for a lot of interesting stuff, but it's quite different from ggplot. And so my curiosity which is basically the key idea of StatsMakie, is can we choose smartly a set of custom types and use them so that the syntax will look like ggplot. It will have all the kind of nice readable syntax to plot data, but in practice it will be run as a recipe. And I think I will try to go gradually on basically the same example as they as I showed in ggplot, to see how you would go about achieving this with a set of recipes. So MPG is our data set. So normally to do a scalar type, you would just pass in the 2 columns. And this can get a bit boring if you start having many columns. So the first trick is to implement the data wrapper, which is basically a way to tell the recipe system that once you get one of these wrappers, all the other symbols will be turned into the corresponding columns. And of course, it doesn't have to be just symbols. You can decide a set of data selectors. So now already you have divided basically the data specification from giving the columns. And finally, this I think is the most interesting one, because it's the one that is slightly less trivial, that you can pass. There's a custom group object that gives you the grouping specification of the plot. So here I'm telling that, basically I'm telling what column I will use to split, in this case just one, and this is run after data. So first I replace this guy with the actual column, so this will become a vector, and then what it knows how to do is to split the data and then make one plot or series, depending on terminology, per group entry. So this is the first thing where I would like to figure out what's the clean way to do it, because in practice this combination of arguments actually gives you 4 series here, one per class. So it's kind of hacked together right now with a custom multiple plot recipe, but it'd be ideal if there were if there were kind of a cleaner solution. And of course, you don't need to stop to just one attribute for the grouping, but you can give many. So for example, here I'm picking 2 columns, and one will set the marker style. So I will choose between the circles, the crosses on the triangle, and the tilted squares and whatnot. And instead, another variable can be used to set the color. And so basically the pipeline will do the grouping, and then for each of these, the unique values of these things, we'll look into the default theme to figure out what is the actual value of the attribute. So these whatever RGB values here, or these various marker shapes. And I think it's kind of important that it goes into a default theme, because it's a way to make sure that these plots look decent. Because if you try, I mean, you can give it by hand, and it's gonna prevail over the theme. So it will choose between the theme that you are using and the custom value that you pass. But it's very hard to make this look good if you put values by hand. I think as humans, we are very bad at choosing a set of colors. So so this is actually closely linked to being able to customize the default theme in a sensible way. So you wouldn't really want to pass custom values all the time. You just want to reset the default theme, and this will look from a novel theme that you have chosen, and then all your plots will have a new consistent look. And so this is for the group, which basically correspond to styling by a categorical variable in a ggplot. And instead, if you have a continuous variable, you do the same thing, but it's just called style, which is, it actually really doesn't do much. It's just a way of saying that the keyword arguments that are passing here are actually columns. So this is helpful so that StatsMakie knows that that is also a column of the data set, and if I split the data, I should also take into account this column here. but I'm not 100% happy about this style thing. So this may be something to discuss in a kind of a dedicated group later. And finally, the final ingredient that I need is the so-called analysis. So this is another recipe that tells you that if the first argument is a function analysis, then after grouping, I will run it on each of the group. So for example, here, if I had to describe how this plot is done, I take my data set, I replace these and these by the respective columns, I split by the group, and then for each group, I compute the density. And the interesting part, which I think is kind of a unique advantage of embedding grammar of graphics into a recipe-like package like Makie, is that basically this analysis object can return any custom Julia type as long as we know how to plot it. So this one will actually return just the kernel density, because then we know how to plot it and we will continue the pipeline. And I also I think I'm trying to implement the same design as Simon was discussing in the Makie redesign, that we shouldn't merge all the keywords together and then let the software figure it out, because it's a mess. So the arguments, the attributes that belong to the analysis, that should go to the analysis. So now if I wanna more or less smoothing, I should change the bandwidth attribute here, and I would have smoother or finer density plots. Instead, the attributes of the plot, they go to the plot. I think this is by far the cleaner design, and I would also insist that even in Makie we make this somehow the default. And so basically, as a final kind of combination of all of these, we can put it all together, and I can add, I can do the same plot as I was doing before, which is this scatter plot with the data grouped by some variable, and I can put a linear regression on top, which is simply an analysis that takes a data set and gives you kind of the coefficient of the regression line. And so basically, if I do this, it will do the correct thing and just plot the linear regression on top of each group. And but the only thing that so just like Simon, I'm a bit of in an unlucky moment to present this stuff, because I was also thinking to have a kind of redesign of the interface, because I think that I really don't like about this is that there's a lot of repetition. So basically what happens, for those of you who are more familiar with the grammar of graphics, is that each of these plot call is, please interrupt me if it doesn't make sense, because I really just thought this like a couple of days ago. But the issue is that each plot call here corresponds to somehow a layer in a ggplot or gadfly. So they call it a layer, this kind of individual thing. And here I'm doing two layers. And I think my overall remark is that these layers in practice will overlap a lot. So a bunch of stuff will be the same. It's the same data, the same grouping, the same column. I just changed that this was scalar and this is linear, but it's the only thing. And what I thought is that it actually has a bit of an algebraic structure, so that we could try to combine this guy within a layer as a product, and then add layers together with a plus, so that the common things can be factored out using the distributive law. So this sounds a bit crazy, but let's just show an example.
Do you know that that's actually the format of ggplot too?
Similar, but not quite. So from what I understand, and probably you'll correct me because I've only used that once, was surprised that it worked, and I never opened it again. But I couldn't wrap my head around it. But I'll keep playing with it, because I think there's some very good ideas. I think I think, well, this will sound very arrogant of me, but I think they got it wrong in that they use it only one operator, which is the plus, but you're actually doing two very different things because so their plus is our star, pretty much like strings, and for the same reason, because it's not quite a commutative things, because um, I think that you can use it to, it's a bit more like merge. So you are merging all of these things together and write mostly expressing. So I'll try to walk you through some example. So for example, this is the same as before with whatever data, and I need custom types everywhere because otherwise I would be type pirating star. So this is the key building block, my column, so the data and the selection. And then I can say, okay, I can add a group, and so I just multiply all of them together. And then the trick is that now with the series, I'm actually adding because I'm combining two things. It's kind of two different layers, that the scar layer and the linear layer. And then what this will get you will be basically, if you distribute this thing, will be a scatter of the data with this grouping, and then a linear of the data with this grouping. And the reason why I think that is different is that I'm actually not sure if I don't have a good example here, but basically the reason why it's interesting to split is that here I could have refined the grouping, for example. So in scatter, I could have multiplied here times another group, and this would be merged with this and would give me a finer grouping for scatter than I have for linear. Or I could actually sum together two data sets here, and then all the plot will be repeated for different data sets. So I think it really gives you more power to have two operators. But this is something for where I would really love to have kind of a dedicated discussion with long-time R users that can give me basically some feedback on how this feels from a user perspective.
I've written the ggplot2 version of your code on Slack in the Vizcon channel.
Thanks. Yeah, look it up because I think it's interesting because it. I think that somehow they only get away with doing one operator, and I think in some cases you can trick it to do the right thing. But I really think it's too. I would really like to get a design where star is their plus, and plus is how you add together layers. I think this is strictly more powerful, but I need to make a better case for it.
I guess one comment that maybe is a little bit too detailed right now is that layers in general are not going to commute, right? The order matters. So perhaps plus isn't the right operator to use there.
Yeah, so I'm cheating a bit, I agree, because so star is really non-community because I want star to allow me to override things. So for example, if here it was linear star group color equals something else, if this is after this, I would like it to win. So I want a kind of a clearly non-community operator where rightmost wins. Plus is almost commutative, but yeah, I agree that there's an issue of the drawing order. But let's discuss in more detail.
Yeah.
Later. And but so just to summarize, what I've shown so far is that basically you can reproduce something that is akin to grammar of graphics with just these four basic types, and in terms of, and I'll have just a couple more slides to discuss to basically discuss the future direction. And I think the first thing that I want to mention is that this has actually nothing to do with plotting. So I've been experimenting to to take it out. So basically, you really just want to find some algebraic structure on these custom types to combine a grammar spec object, and you want to explain how to turn this grammar spec into a list of traces, which will which is very similar to a list of series, but in a descriptive way. So just basically grouping variables and data and stuff. And the only, and I really think that these custom types could live in a separate package. So then various plotting things can decide how to render. The only thing that that I expect from the plotting package is that if I pass you a list of these trace spec, that you know how to plot them. It's the only requirement. And this basically we rely on the on the kind of use this kind of user and type series which return multiple traces. And the final thing to discuss is the which is I think of a pain point right now, is that there isn't really a concept of I need to put layout in this, and I haven't so far. So there are some layout-like things. For example, you can give it a stack, and it will know that it has to stack things together. But there are all ad hoc implementation, which is implemented again with convert arguments that it knows how to convert if it encounters these. Or for example, violin plot has a side attribute which tells it on which side to plot, so you can easily get this stuff. But I would really like a way to somehow in each of these for each of these guys, for each trace, to pass the list of kind of recommendations for the scene, that they should somehow communicate to the larger scene how they want to be rendered. So for example, if instead of side by side, I want to make these on two horizontally stacked plots, somehow I want to have a layout field. So I want to be able to say row equals year and I split by row and I have two separate plots. And but the only thing is that I don't know what attribute to pass where. So this is definitely something would need to be figured out in the kind of in this more detailed in the more detailed discussions. So basically, in terms of future directions, which means kind of reasonably short term, like hopefully this weekend, figure out the syntax. So I really want to get a lot of feedback from basically R and non-R users on what they expect and whether it's intuitive to have two operators instead of one, or if it's just a mess. And these two things are basically the same. So as I get more info from the data and from what the user is giving me about what the legend should be, what the labels should be, the ticks should be, or the layout, how do I pass it forward in the recipe? How do I tell I'm expecting these ticks because I just converted this categorical variable? I expect this legend entry because I encountered this group. And then there's a bunch of work that does not require deep of understanding of the internal, which is to define more and more stats. I think the big one that we're missing is adding standard error to the analysis. And then there are a few more very technical things that I think it would be important to discuss. So how do we implement with the new recipe system? Can we make it easier? Now I have hard-coded data, group, style, and so on. Can we make it easier for the user to add a new one? Maybe they come up with a new atomic element of grammar or graphics and want to try it out. Can they do it by overloading something? And finally, this is the, I am throwing it out there because I think it should be discussed also in the Maki recipe. This was a bit of a pain point in plots, which is how do we plot many things? Because we have this kind of nice default that if I pass you many columns, you put them one on top of each other. And this was, I don't know if you remember, Michael, but this was painful for a long time. That we were like, okay, but how about if the correct thing is not putting them one on top of each other? So we had this this issue that, for example, the default box plot, if you have many columns, is to put all the box plots superimposed, which of course you can't read them. And I would be really curious if you can somehow figure this out. So can we have a good default for a plot type with multiple plots just superimpose, but allow good customization? Like, I don't want superimpose, I want to stack, I want to dodge, I want a different layout. And so I would, it's not crucial, but I think it'd be nice if we could discuss it in the Maki recipe section. And that's that's pretty much what I got. And if, I guess some questions we can have now, and otherwise we can just postpone for the discussion later.
I have a few questions, but I think I will just postpone them.
So I felt a little bit, first of all, these are really amazing talks. It was so useful to see all of them.